So I like to welcome you to one of the two last talks of the first day of Hash Days. I'm going to talk about firewall rule reviews. And yesterday when we were at the speakers dinner, a long-term colleague of mine told me, well, your topic is very old and very dusty, and I won't come to this talk because it might be very boring. And so I'm very glad that so many people are using Apple Maps and are lost in this room instead of the other one. Um, well, of course, firewall rule reviews is a very traditional topic in my opinion, but I think we have a lot of experience collected in the last 2 decades, and I'd like to present you some of our experience in this field. After a quick introduction, I'm going to explain our approach to do the modeling of firewall rules and to do the reviews. And then we have enough time in the end, we may ask some questions. Well, first of all, who am I? My name is Marc Ruef. I'm here from Switzerland. I'm for the third time presenting at Hash Days. I am co-owner of a company called Skip in Zurich. We are providing consulting services and we are doing some auditing and forensics, and I have a website and I wrote some books about the topic. Well, the goal of a firewall rule review is you want to determine insecure rules to increase security. You want to determine inefficient rules, wrong rules, and obsolete rules. And if you are able to identify those rules, you are going or you will be able to improve the quality of your firewalling. So I will show you different approaches and our methodology, how we approach firewall rule reviews. And if the time allows it, I'm going to present you some further possibilities. Basic question is, are firewalls rules obsolete, or are firewalls obsolete? In this May was a quick and short shitstorm in the blogosphere and on Twitter. Many people think that firewalls are obsolete and it doesn't make sense to use firewalls at all. I don't really share this opinion. I think firewall is a good way to improve network security. But of course, you shouldn't rely on firewalls only or antivirus encryption, whatever. It should be a holistic approach which respects all different kinds of threats and possibilities. Of course, if the core of your network and your applications is secure, you wouldn't have to use firewalls because everything would be perfect, but we don't live in a perfect world, so firewalls might help you to improve the security of your environment. These are the steps that are required to do a firewall rule analysis, and we will go through them. First of all, you have to extract, First of all, you have to extract the firewall rules, and then you can work with the firewall rules. You may be able to parse the firewall rule sets, dissect different objects and services and stuff like that. And then you might be able to determine global settings, which leads to the possibility to identify weaknesses and to eliminate them. There are different approaches how to work with firewalls and firewall rule sets. We prefer exported files. That means we say a customer that he has to send us the configuration setting or the rule set of his firewall because it's much faster, it's more reliable, and we don't have a user-face abstraction layer. And I will come to that later. But still, screenshots might be a good idea, or an on-site analysis where you sit in front of the front end of the firewall. You got an easier walkthrough. You might be able to enhance your report with visual aspects, and it's usually much easier to do some cross-checks if you want to parse the firewall rule sets and you have some implications. It's usually good to see is your implication correct also on the user interface. And sometimes it's your last hope because you only can work with the user interface because some firewalls don't allow you to export the rule sets properly, or you will get a quirky file format which you're not able to parse, and so it's your last hope to approach the system. Getting the firewall rule sets is not easy, and it's different on every different product. As you can see, Astaro has, for example, 3 different ways to export the firewall rule sets. And the funny thing is, these 3 different ways won't collect the exact same rule set. You will get a lot of the data will be the same, but there are some differences, and it depends how the customer was able to export the rule set, what you can do with it. And there are different formats, whether you do an export with a script which is pretty much undocumented, or if you do the backup and restore on the web admin interface. Yeah, it's usually the customer is responsible to bring us the firewall rule set, and we have to give him a step-by-step how to, and sometimes it's not that easy because for different reasons he can't access different services, or he has disabled services, or he has a very old product that doesn't support, for example, SSH or whatever. So sometimes it's a bit hard to communicate with the customer to get the data that is important for you. If you get the firewall rule set exported, there's the next problem approaching. It's that the different products use different formats for the firewall rule sets. So, for example, Astaro, Checkpoint, and FortiGate have array-based rule sets, which is primarily cool, but sometimes hard to read if you don't parse it. I personally prefer command line based rule sets because they are very simple, 1 line, 1 rule. Cisco and Citrix Netscaler are very popular. And some products use ini files. Most popular examples are McAfee and SonicWall. Yeah, it's very traditional, but it works. What's very different or very exotic is that McAfee Web Gateway provides ini file, an XML file as an export, but inside the XML file is embedded or encapsulated an ini file. So they say they are able to export XML files, but basically it's just a container for ini files. And you have very different understandings for XML files. Airlock, ClearSwift, and Totemo Trustmail all use XML files, but the config format is very different, and they have a very different approach how to create the whole construct. So if you are able to write a parser for a firewall rule set, you usually or you never are able to use the same parser for a different product. So this is an example of Cisco ASA. As you can see, 1 line, 1 rule basically. I like that because it's very simple, and simple is always good. This is part of a checkpoint rule set. As you can see, it's more like a tree. You are able to do connections and to do more complex stuff, and it makes it much harder to understand the firewall rule set and to work with it, especially if you haven't parsed it. So the basic attributes of a firewall rule for me is you have a source, host or net, you have a source port, destination host, destination port, a protocol on the connection, as you can see here. Some firewall allow additional attributes for your rules. For example, you can define time frames, or you can define priorities, quality of service, whatever. And that's very, very nice to have, especially if you want to improve the security of your environment. But firewall rule analysis becomes much, much more complex if you have attributes which are kind of exotic. If we do a very simplified firewall rule analysis, we focus on the 6 basic attributes. But if there is a product which introduces an additional functionality, we try to respect that too. And sometimes it's not easy because you don't really understand what is important and how the different features work. So then we try to create a table-based format of the firewall rule set as a very simplified form. As you can see, the 6 basic attributes of a firewall rule. And then we try to find weaknesses in these rules. And these are few of the things on our checklist we are trying to identify. The worst thing basically are any rules which allow any traffic, and there are more complex weaknesses like mashup of objects. For example, if you have in one rule a high security system and also some kind of public service is defined in one rule, and the same rule is applied for both objects, but they aren't very at the same level of security, it's very problematic. And of course, we try to identify insecure rules if you use very old school protocols without encryption or overlapping objects and stuff like that. Usually you have to have a lot of experience in the network field and in the application security field to understand how these weaknesses really affect the firewall rule set. That means most of the guys that do the firewall rule analysis at our company are coming from the network, and they understand the problems. They have integrated firewall systems or they have maintained them, so it makes them a bit of a head to understand what the problems might be. Then we try to identify these insecurities. For example, the any rule, there are some here, and we try to identify the risk for the different rules. And then we suggest how these risks might be mitigated. Of course, to understand the target network of a customer, you have to understand the processes, you have to understand the layout, the topology of the network. So sometimes our suggestions are not respecting these details. So it's often so that the customer says, no, we can't implement this because this product has to use Telnet because it doesn't support SSH and stuff like that. But usually the primary goal is to tighten the rule set as far as possible without distracting the daily work or daily traffic on the network. A simple firewall rule analysis of an inline element is very simple, but most customers try to run redundant firewall environments. And then if you have to do a firewall rule analysis, you have to respect that though there are two different firewalls and basically they have to have the same rule set, but it's not easy if you have high redundancy and you have to verify, cross-check if the rules are exactly the same. It takes quite a lot of work, or you have to do a lot of parsing. And in most cases, when a customer says they have a redundant system and both firewalls are installed exactly the same, that's never true. It's only true if they do it automatically, if they have scripts which are mirroring the system and the rules. But if they try to do it manually, it always fails. We have always differences. From an attacker point of view, it's usually interesting because if you have a firewall rule established on firewall A and not established on firewall B, you hope to get the traffic to firewall B because you aren't limited with this path. Another level of complexity comes with multi-tier firewalls. No firewall allows a direct connection between 2 points. If you have a single tier firewall, or an inline element, you have point A which communicates through firewall to point B. And if you have a multi-tier environment, you have multiple firewalls chained together, and this introduces additional complexity because you have to consider every tier, and the effort grows exponentially because you have to if you put different firewalls in line and chain them, you have some kind of mashup of rules. Sometimes there is a rule on the first firewall and there isn't a rule on the second firewall. Sometimes it's swapped. Sometimes there are rules on both firewalls, and you have to find out what kind of traffic really goes through all these elements or all these these different firewalls. Furthermore, you have to find out what the priority is of the firewall rule set. Sometimes, for example, if you have a firewall rule which is combined with an intrusion prevention system, and the next firewall isn't, it's sometimes really hard to find out what the real world or the firewall rule set is that is really established in the real world. So because it's really hard from a reviewer point of view to understand the whole complexity of the system, we always suggest and suggest towards our customers to do a workshop to discuss our findings, to discuss our approach, to discuss what ideas we have. And sometimes the customer can give very good feedback, more information about network topology or routing aspects, and then you realize that some vulnerabilities or weaknesses you were referring to aren't really established in the real world. But firewalls aren't that simple anymore like, let's say, 15 or 20 years ago. You have a lot of additional features, antivirus, or you have caching, you have HTTP proxy capabilities, and many firewalls allow global settings. For example, you can define, okay, I want to enable antivirus for all communications, or I want to enable auto-update for this antivirus. So firewall rule analysis also have to respect these global settings, and sometimes they are not part of the basic firewall rule. Sometimes they are part of an additional config file, and you have to find out, okay, SonicWall is storing this data there, and you have to collect all the data, and sometimes it's really not easy, especially if a customer comes to us with a product that we never have tested before. We usually have a few days to find out how this product really works and how we get the data that is important for us. For the global settings, we have the same approach like for configuration reviews. We are identifying all different settings that are provided. Then we identify the current value. We determine the recommended value, the value that we recommend to increase the level of security. And if there is a difference, we provide a risk rating for this potential weakness. So if you have done a firewall rule analysis of the traditional rules, and if you have done a config review of the global settings, you give the recommendations to the customer, and he is going to implement most of them, hopefully, or all. But there are rules remaining. Some rules can't be touched because they must be like they are, or the new rules, the improved rules, have the best level of security, but they have to be like they are because you want to provide a service. So our idea is to rate the remaining rules, or to rate the established rules, and we have different approaches, and we aren't really didn't really came to a conclusion. We are still experimenting a bit in this field. So one of the approaches is to use CVSS to rate the different rules, and here is a very simple example for typical connections over a firewall, and this scoring should help you to see, okay, this kind of communication is the most severe or is the most risky because there are the systems are very important, or very insecure services are provided, or you have a very wide attack surface. So this list would help you to identify rules which, if you could, you should disable them and use different approach to provide the data in your network. So we did a lot of firewall rule reviews and tried to collect some statistical data. Here you can see the findings, the different findings we are looking for with our checklist. And this graphic illustrates that two different things. There are problems which usually affect most customers. Typical problems are that the logging of rules isn't really enabled. Any rules is something that you find everywhere, sometimes sooner or later. And this graph shows the most, or the findings that we see the most. Any rules, bidirectional rule pairs, again, any rules with the destination that contains any. So really, an any finding is always a high finding, and we always report it and think that that's not correct, because that's not a tight firewall rule set. If you want to use any rules, you could put a simple router in it, and it does basically the same. When we do a firewall rule analysis for the first time, we see I've used the bigger projects with at least 300 rules. We see for the first time analysis between 20 and 30% of the rules that contain weaknesses, and we suggest our customers to do an analysis, and we especially if the rule set is always changed and there are improvements, we still see between 7 and 10% of weaknesses in the rule sets. We suggest to do an analysis once a year, a full analysis, and it makes sense if you have further changes or larger changes to do an incremental analysis of the changes. So why are there so many problems in firewalls? I mean, the topic is old and dusty, as said in the beginning. But still, we are failing with the same problems that we did 10, 20 years ago. There are many mistakes, a lot of laziness, and a lot of misinformation and misunderstanding, especially if you in larger environments, corporate environments. It's not unusual that the person that implements a product doesn't really know which kind of ports that are required, and the vendor states, okay, we need 30,000 ports to communicate with the different hosts. That's not unusual, and because time is precious, they put in an any rule or a very wide definition of ports, and yeah, that makes rules much insecure. So that was my presentation. I like to summary. Firewall rules are very important. Extraction, parsing, and dissection of a firewall rule set is a very interesting thing, and I think it makes sense to work with firewalls and try to improve them, because they are still an important part in the network. And we always see the same weaknesses over and over again. That's not a problem for us, because it makes our job a bit easier, but it's a problem for the customers. Yeah, because it seems that's very hard to improve for them. Yeah, and the good firewall rule analysis respects the peripheral aspects of a firewall rule, like rule comments and logging are nearly as important as if you have a broad definition of ports or if you use any rules. There is some documentation how we do that. Everything is on German. I'm sorry for that. And have a nice day.